Okay, guys, today we're going to start talking about transformations. First off, when we're talking about transformations, we are not talking about cars and planes that turn into giant robots. We're talking about graphs that are going to move around on the coordinate plane that we have. In order to do that, the first thing that we're going to get into is parent graphs, and then we're going to adjust them all over the place. If you guys recall the other day, Captain Boyd was talking about parent graphs, okay? So how are we going to start this with our transformations here? The first thing that we need to see is what is my parent graph. Well, this right here being the graph that we're actually trying to move around, this right here is the parent graph. In other words, the most simplest form that we possibly have. So y equals x squared. If you recall, that's a quadratic, and it creates a parabola on the graph that goes up, just like that right there. Now when I'm trying to do my transformation, now I look at the things that are changing, the things that are different from the parent graph, which is right here, all the way to the equation that we are dealing with. The only thing that's different in this case now is the -3. The transformations that we will deal with are going to move our graph either up or down or flip it over entirely. And we'll get to flipping it over here in just a minute. But this right here, -3, if you see a minus sign, typically what does that mean to you? To me, that means going down. That's a negative idea. So from this point right here, the middle of my parent graph, I'm going to go down 3. 1, 2, 3. And now I'm going to draw the same graph from right there. So the blue graph is actually the graphed representation of what we have right here from our formula. Moving on to the next one that we have. Again, if you guys will recall, here's the graph, or here's the function that I'm trying to graph. Okay, y equals the square root of x plus 2. Again, you had a parent graph, and that parent graph looked like this right here. So y equals the square root of x. Hopefully you guys will recall, again, from the parent graph video that we had, that the graph actually looks like this right there. So there's my parent graph, okay? Again, we're looking to move graphs up and down or flip them over. Because of the fact that I have a +2 right here, okay, again, I'm going to go back to the origin, or where did I begin? Here's where I began right here at the origin. And 2 being positive, I'm going to go up. So from here, I'm going up 1, 2, put a point right there, draw the same exact graph right over the top of it. So the blue graph is the actual graphical representation of what our function says right here, okay? Keep in mind, guys, if you look at the graphs that I'm drawing here, they are not extremely precise at all. They don't have to be. Now, at the same time, they can't be crazy, messy, right? Don't look like, you know, you're really right-handed, but you're writing left-handed. That's a poor idea. So we need to get it as close as we can to what's right on. However, don't spend all afternoon trying to make it like you're a computer. Okay, our next example, y equals the negative absolute value of x. So again, the first thing we need to identify, what is the parent graph? Well, in this case right here, again, if we remove this, we see that our parent graph is just y equals the absolute value of x. What does the parent graph of that look like? Again, if you recall from the other day, it makes a V. We've got 2 straight lines shooting right off the origin, just like this right here. There is the parent graph right here of the absolute value of x. So what is the difference this time? Well, the last 2 examples that we had a plus or a minus sign out here. The plus or the minus sign told you to move the graph up and down. The difference in this case does not have a plus or minus sign. What it does have, though, if you look here, nothing is in front of the x, okay? And if we look right here, there's a negative sign. Anytime that you have a negative sign, simply do this. Take the graph, whatever the parent graph was, again, that's in black, and flip it over. So if it was shooting up like this, collecting water as it rains, then we need to turn it over and dump the water out. So the blue now becomes the actual graph of the function y equals the negative absolute value of x. A negative sign, guys, flips the graph over. Flip it over entirely. Okay, now the most complicated one that we have right here with this particular lesson. A couple of things are taking place. First thing that we need to identify is what is the parent graph. So here's our function y equals the negative x squared plus 5. what's the parent graph look like? None of our parent graphs, guys, had y equals and then some number. They always had a variable. So when I'm trying to find the parent graph, I need to identify the variable. Obviously, it's x. So in this case, what we have to be my parent graph is simply y equals x squared. All of those things stay together. Recall, what is the parent graph of y equals x squared? What does it look like? It is a quadratic, therefore it's a parabola, and it looks like that. Again, keep in mind, guys, when I'm drawing these things, I don't have to be exactly precise with the graph. However, chicken scratch and sloppy isn't going to fly either, all right? So if you're right-handed, make sure you're using your right hand. Now, what are some changes that we have right here? The changes that we have, first thing that's glaring is it says +5, okay? And in our parent graph, we don't have a +5. Well, recall, what does the plus side, or what does the +5 make it do? Well, if you said it makes the graph go up 5 spaces, you were dead on. So 1, 2, 3, 4, 5. Now I'm going to put a mark right there, but I'm not going to draw a graph yet. Why? Take another look at the function that we have that we're actually graphing. Are there any other changes or transformations that need to take place? And in this case, yes, there are. I've got a minus sign out here in front. From the last slide that we just did, what does a minus sign make it do? Well, this parabola should go up when it says y equals x squared. The minus sign will then make it go where? Down. So from my new point, that's the +5, instead of a parabola going up, I'm going to make a parabola going down. So my blue graph here now is the actual graphical representation of the function y equals negative x squared plus 5.